So now that we've talked about factory methods to create fluxes, let's start talking about other kinds of operators that can be used to do other things to a flux, in particular, transform them. It's the first topic. And we're going to be talking about map and map not null, which are used to transform the values and or the types that are emitted by a flux. So let's take a look first at the map operator. This is used to transform the items that are emitted by a flux. This is going to look very familiar. It's very much like what we had with Mono's map, just working with fluxes, not with a single value. And what it does is it applies a synchronous function that's intended to be used to transform each item. So we pass in a function that'll be applied to every element in the input stream that we get, the flux stream that we get coming into map. Now, map can actually terminate if the mapper function throws an exception, but assuming it doesn't throw an exception, then it will return a transformed flux where every one of the elements in the input stream will have been transformed by the mapper function one way or another. Always keep in mind with map, especially map for things like fluxes or observables or streams, that the number of output items must match the number of input items, unless, of course, an exception is thrown, in which case all bets are off. But if there's no exception, then you'll have an equal number of output elements that have been transformed as you had input elements. So, for example, here's a simple use case that we'll look at later when we talk about the case study, where we take a big fraction list and we use from iterable to convert it into a flux stream. And then for every element in that flux stream, we're going to use map to multiply each of the big fractions by some constant. So very simple. This should look old hat. This is very much like Java streams and the way that map works there. Just like with Java streams, map can transform the type and or the value of the elements it processes or not. It depends on what you want it to do. RxJava has a map operator that works identically to Project Reactor's Flux map operator. And this, of course, is also very similar to Java streams map. Here's a fun little example where we're going to create a list of 3 lowercase strings, ABC, and then we convert that into a sequential stream by using the stream factory method. And then we use the map transforming operation in Java streams to uppercase each of the elements in the stream. And then we collect it into a list and return a list of uppercase strings. So fun, easy, familiar, hopefully. Let's take a look at another variant of map. This is an interesting one. This is called Map Not Null. And it also transforms the items that are emitted by the flux using a synchronous mapper function. That's the same thing. The difference is the mapper function can produce null values. So it may produce null values. And any null values that the mapper function creates will not be emitted. It's almost like you're filtering them out. So this is kind of a combination of map and filter. And the reason that it does this is because null is not a supported value, so you can't filter it out. This is a really, really obscure quirk of Project Reactor, and I think of RxJava works the same way. So it's kind of equivalent to map followed by filter, but the difference is that if you map something and you get null values, you can't filter them out. So you need to use map not null instead. It can also throw an exception if the operation needs it, and in which case it won't terminate, or it'll terminate early. And otherwise it returns a transform flux that will not emit any nulls, even if the mapper may emit nulls. So here's a very simple example, which we'll also take a look at when we look at the case study later, where we're going to go ahead and create a big fraction. And this is kind of crazy, just to demonstrate how this works. We're going to make a pair of big fractions using just, which will be in a stream, a flux stream. And the first big fraction will be 100 over 3, and the second will be 100 over 10, which of course is 10. And then we're going to use map not null, and we're going to check to see if the big fraction equals the constant 10, which of course this one up here will, the second one, big fraction value of 110 will equal 10. And if that's the case, we return null. Otherwise, we return the big fraction. But all that will be printed here will be the big fraction that was not equal to 10, because nulls will be excluded. That's obviously a bit of a contrived example, but you'll see plenty of real examples that are not contrived that work like that. As with map, you can transform the type or the value. Interestingly enough, Rx Java's observable lacks a map not null operator, which is a little bit weird. However, you can use an optional to do this. So this is what you call desperate times call for desperate measures, right? If you don't have a way of being able to filter out nulls, then you use this little idiom. So what we're doing here is we're taking something and we're using optional nullable, which will create an empty optional if the value is null. And then we can filter out empty optionals by only allowing things that are present. And then we go ahead and get the results. So yes, this is a bit of a hack, and this is why Project Reactor's Flux has a map not null method to avoid having to do crazy stuff like this. There's also an interesting concept in Rx Java called a transformer, which has nothing to do with data science transformer models. But we can also write a Map Not Null Transformer, which then contains all the gobbledygook needed to get the right behavior here to ignore nulls. This is actually really, really, really cool if you look at it carefully what it's doing. It's basically taking in a mapper and it's going ahead and calling flat map. It's applying the operation. If the operation is null, it returns an empty observable. Otherwise, it returns an observable that just emits that item. So basically, it's giving out empty results. And then we can use this map not null method, which is basically, this is a way in Project Reactor or in Rx Java in this case, that we can add new operators above and beyond the ones that come out of the box, right? So Flux has like 300 operators. Rx Java's observable has like 300 operators. But sometimes they just don't go far enough, as in this case. So we can use these interesting things. In the case of Rx Java, you can use this thing called compose. And compose can be used to take your own operator and apply it as if it was built in to the observable. There's a similar thing that's part of Rx Java, that's part of Project Reactor as well. That's a little bit of a discursion here, just letting you know that you can work around this weird problem with Rx Java if you define this transformer kind of thing. Okay, so that's the end of the discussion of kind of the core transforming operators in the Flux class. It will come as no surprise to you that there's also a boatload more of them. Things like flat map and flat map many and so on and so forth. And we'll talk about all those things.